In the transport layer, we saw that there is segmentation done to our data. Sequencing is done for each segment, a number is given, and we also saw there are port numbers. For example, telnet 23. 23 identifies telnet. 80 identifies HTTP. Likewise, we have various protocols and a number for each protocol. For example, file transfer protocol. If you take file transfer protocol, this file transfer protocol also uses TCP, and the port number is 2021. Two port numbers for file transfer protocol. For telnet, we saw 23. For HTTP, we saw 80. For HTTPS, it is 443. See, these numbers are called as port numbers. These port numbers are used to identify a service. FTP is a service. HTTPS is a service. Telnet is a service provided by network. HTTP is another service provided by network. No. So these numbers are also assigned by this transport layer. Transport layer assigns source and destination port number. For example, let's go back to our previous scenario. We have a computer called A, another computer called B. And A's IP address is 10.0.0.1, B's IP address is 10.0.0.2. Suppose A's MAC address is AA and B's MAC address is BBB. A is telnetting to B. So what will happen in transport layer, it will assign the source port number, a random number, random port number, and that random port number will be greater than 1023. And the destination port number will be 23. See, the source port number is a random number. Destination port number, meaning when this destination receives the packet, the destination, by seeing 23, it understands A is looking for telnet session. So the 23 is the port number, reserved port number. But the source port number is not a reserved one. Port number between 1 to 1023 is reserved. This is reserved port number. See, the source port number, it's a random number and it is above 1023. Why it is above 1023? Because up to 1023 it is already given for various service, like telnet 23. அனுப்புறவங்க சும்மா ஒரு போர்ட் ஒரு சோர்ஸ் போர்ட் நம்பர் போடணும். அதனால சும்மா போடணுங்கிறதுனால ரேண்டம் நம்பர். ஆனா இந்த பாக்கெட்டை பெறுகிறவன் இந்த பாக்கெட் எதுக்கு வந்துச்சுன்னு தெரியணும் உனக்கு. அதனால டெஸ்டினேஷன் போர்ட் நம்பர் சர்வீஸ்க்கு ஏற்ற மாதிரி மாறும். 23ன்னு போட்டா அதுக்கு புரிஞ்சிடும். Destination will understand that this packet is demanding a telnet connection. Now this is also correct. For example, if port number 80, A puts port number 80, B understands A is looking for a HTTP session. Because I told you above, 80 is for HTTP. You remember yesterday I told you the vending machine. You put the right number so that machine will understand. Yeah, it understands what you look for. Yeah. So here in our scenario, it is only telnet, so it's 23. And who does this? Who assigns this? It is transport layer. See, we see that transport layer is doing a lot of work here. It is segmenting, it is sequencing, it is assigning port number, and also it decides whether to use TCP or UDP. Now, when we learn TCP, we learn that it is a connection-oriented approach of transferring data. UDP is connectionless. I give you an example. When I call someone, as soon as they pick the call, I say hello. On hearing my hello, the other person on the other side says hello back. So from his hello, from his voice, I know that I'm talking to the right person. Then I start telling the actual message. That is what connection oriented. So when I'm talking, if he's not responding every now and then saying, yeah, okay, is it? Something like that. If they don't do that, I keep calling, hello, do you hear me? I keep calling to check that the person is still available on the other side. Same way, TCP will also check the other side is available or not. You know, we call it as connection oriented. UDP will never check. UDP is like I call someone, I didn't even say hello. Yeah. As soon as someone picks the call, I keep talking. I keep talking like, automated message you used to get in cell phone. Sometimes someone calls, we think someone is calling. Yeah. When you pick the call, you didn't even say hello, but someone is already talking in Hindi. உங்களுக்கு தோசை வேணுமா வடகரி வேணுமா? That is what I understand from that Hindi language. I don't understand any word. We drop the call. Now, what happens is UDP is without checking whether the receiver is there ready to receive or not, it keeps sending the packet. That's UDP. User datagram protocol and transmission control protocol. Now, both are important. See, if there is a very urgent thing, we won't be keep saying hello and all. As soon as someone picks, we will talk. But in a normal call, we say hello, we say how are you, and then only we slowly move into the original message, original content. So both are important depending on the service. If the service is a fast service, like voice mail or this online classes, online meet, WebEx, or if it is a video conferencing. These are all, live telecast, live broadcast, all this live stuff, they all need UDP only. TCP won't suit there. But wherever security is needed, wherever you want the confirmation that the receiver has received it, then you need to go for TCP. But again, we are not going to decide whether TCP or UDP. They're already predefined, configured, designed inside the operating system that we run on our laptop, in our computer, in our cell phones. So automatically they pick this one. Say, for example, you are doing a WhatsApp call or WhatsApp message. Your cell phone is going to pick UDP. But when you try to attach a file in the cell phone's Gmail application, then cell phone will use only TCP, not the UDP. How this TCP checks for the receiver, or how it does this connection oriented thing. Let's see how TCP does this connection oriented thing. Again, I want to remind you, both are important. Wherever there is a need for instant delivery, then it is going to be UDP. Wherever there is a need for reliable communication, then it is going to be TCP. So TCP is highly reliable. That's another point. TCP is reliable. Yeah, TCP is reliable. UDP is unreliable. Okay. Why it is a UDP is unreliable? Because we do not know whether there is someone to receive or not. We don't know whether they have received or not. There's no acknowledgement, nothing. So we cannot trust that it has reached and take some action. But in TCP, we can clearly say that it has been delivered because you got that acknowledgement. Okay, now let us move on to the TCP connection oriented means what? This is what it means. It means three-way handshake. Three-way handshake. Three ways. Meaning, two computers, before sending any packet using TCP, they will just do a handshake first. If the handshake is successful, only then they start sending the data. That is what we call as connection oriented. That is what we say demands acknowledgement. Say, for example, A wants to send data, a big data. B also want to send the data. Now A first approaches B. This is the first handshake. It says, I am sending you a sequence number 700 packet with acknowledgement, nothing in it. What is acknowledgement? If you would have received something earlier, you would have acknowledged. But A is the first talker. So acknowledgement will be nil. But A is sending this packet, but this is not the original data. This is just for the three-way handshake. This is just for connectivity check. It is sending a dummy packet with a sequence of 700. See, for your understanding, I wrote 700, but usually sequence number will be like a 6-7 digit number, big number. So now the packet is going to be If B is there to accept it and B is there in a position to respond to it, then B will also send a dummy packet. See, B also want to send data. So B will send a dummy packet with a sequence number, let's say 300, and an acknowledgement of 701. B is saying 701. When A receives the 701, A can understand that B has already received my first handshake 700. Only then B can say 701. No? If B did not receive that 700 packet, B cannot send this number 701. B is sending 701 to say, ஆனா இந்த நம்பர் இன்க்ரிமெண்ட் ஆகுறது டெமோ கிடையாது. கரெக்டா ஒன்னு இன்க்ரிமெண்ட் ஆகும். 700ன்னு வந்துருந்துச்சுன்னா பி என்ன பண்ணும் 701ன்னு சொல்லும். So by saying 70, it increments by 1. Correct. Sorry. By incrementing 1, what does it say? It says two things. One is it is asking for 701 because it has already received 700. It has already received 700. So it says, give me the next packet, 701. So as an acknowledgement, it is sending 701. And it is also saying another message. What is that? I can hear you. That's the message it is saying. I can hear you. Because I heard you, I'm asking 701. Now, B is receiving 300. So A is receiving 300 from B. Now A should say, I heard you. How it will say? It will say by sending an acknowledgement of, what will be the acknowledgement of A to B? Well said, 301. All right, so this is what we call it as three-way handshake. This is what we call it as connection oriented in TCP. In TCP, we say it is connection oriented. What does that mean? It does this one first before sending the actual data. All right. So after this, only the actual data will begin. Did you understand? Three-way handshake, connection oriented, TCP. Okay. Now let us move on to our yesterday's discussion. We went up to transport layer and we have learned a lot of things about transport layer. So what I'm going to do is I'm going to copy this portion. Down. Okay. All right. Now, in the transport layer, what happened is the port numbers were given. So what happens next? In the network layer, see, this is application, and then the presentation, and then the session, and then now the transport layer has added the port number, sequenced, segmented, all the stuff is done. And now the IP layer comes. We call it as what? Network layer. In the network layer also another information called the IP address is added. Network layer. What is the number? Layer 3. So what is added here is source and destination IP. In our picture here up there, what is the source IP? 10.0.0.1. What is the destination IP? 10.0.0.2. So that is what given here. 10,0,0,1. Destination is 10,0,0,2. And then this place where the IP address is added, we call our data as packets. What do we call our data in the transport layer? Segments. Correct. Now, to the segment, IP address got added, and this is now called as packets. Now the packet goes to the data link layer, which is layer 2. That is where our packet gets another layer called source, another layer called source and destination MAC address. What is the source MAC address? AAA. What is the destination MAC address? BBB is added. At last, the data link layer takes the data and converts into bits and bytes in the physical layer, which is called as layer 1. Physical layer is called as layer 1. Okay, so what we have seen is there are layers after layer, the information is attached. Now this is what goes to the other side. This PC here will uncover the first layer and it will check the second layer. In the second layer, the MAC address is saved as what? BBB. Am I BBB? Yes, I am BBB. Then it opens the next layer. In the next layer, it checks the destination IP. It is written in the packet 10,002. Now, the PC will check, am I 10,002? Yes, I am 10,002. Okay, this proves that this particular packet belongs to me. The sender has put my MAC address in the destination field and my IP address in the destination field. So only B will open this packet. No other computers can open. Now B opens the packet. When it opens the packet, in the transport layer, the source port number was a random port number and the destination port number was 23. When the receiving PC sees 23, it understands that Telnet is what I need to support. And then the remaining layers like session layer, presentation, application is taken care by the operating system. So what you're understanding here, the sender will add layers. On the receiving side, it will peel the layers after layer like an onion and it gets the data at last. So encapsulation of data happens in the sender side. Decapsulation of the packet happens on the receiver side. Once the 7 layer is decapsulated, the receiver will be able to retrieve the data which is sent by the sender, which is sent by the sender. Did you understand this data encapsulation and decapsulation? The sender encapsulates with the information so that packet will reach the destination and the destination will understand that this packet belongs to me. Once the decapsulation is done in this receiver side, receiver gets the actual data that has been sent by the sender. All right, so that brings us to the end of OSI layer. Do you have any question in devices or in OSI layer? You see, when I have a switch and another switch, and I connect the port between the switch. When I connect like this with some computers, now a computer A is sending a broadcast. What it is sending? What is broadcast? What is broadcast? What is broadcast? It's a packet that is destined to everyone, isn't it? The destination of the packet is not B or C or D. The destination is everyone, anyone, everyone. So when this packet goes to the port, what will happen? Switch will flood it to everyone. Is it correct or not? That is what called as broadcast. Now, you see, when the same broadcast hits this switch, what the switch will do? It will also broadcast. So the broadcast that started here is ending up only here, correct? Which means one broadcast domain. You cannot say this is one broadcast domain, this is another broadcast. No, no, no. It is only one big broadcast domain. If I add another switch, how many broadcast domain now? Listen, I have connected another switch, okay? And yes, yes, yes. Exactly. Even if you have 100 switches, the total number of broadcast is only one broadcast domain. They all form one single broadcast domain. You understood? So you should not say three broadcast domain, it is only one. Now, collision domain. Let's say this is 24 port. This is another 24 port. This is another 24 port. So 24 multiplied by 3, 4 3s are 12, 72. So how many ports totally we have is 72. If these three switches are independent, each switch will have how many collision domain? 24, isn't it? But when I connect the 24th port with the first port here, now this 24 collision domain ends up to here because this port is what goes down here. Likewise, in this 24 port, one of the port goes here. So this will be counted like this: 24 plus 23, because this has been shared. 23. Again, here also another 20. Yeah, minus 1. That is it. That is it. That's it. So this is going to be 70 here. Yeah? 70. Yeah. Yeah. Right. Next, let us take a switch and a hub. Same story. If I connect a hub and a switch, the broadcast that is going from here will stop only in the last port of the hub. Do you agree? So how many broadcast domain we have? Only one. And collision domain. Let's say this is 24 port and this is 8 port hub. This 24th collision domain is here, and hub also has got only one, which is already shared. So how many collision domain? Only 24. Yeah, only 24 collision. You understood now? Now let me ask you another question. I told you each port on a router will have one collision domain and one broadcast domain. Each port has got one collision domain, one broadcast domain. And this is 24 port switch, and this is also 24 port switch. Now tell me how many collision domain in total and how many broadcast domain in total. Correct. Okay. So this broadcast domain of the switch is being shared up to here. So this is one broadcast domain. This is another broadcast domain. So two broadcast domain total. How many collision domain? Mhm. No. This 24 is up to here, right? So this is shared with the 24th. This is shared with the 24th. So totally how much? 48, right? So let me ask you another one. You have a hub connected to a router, and this is connected to a 96 port switch. So tell me how many collision domain and how many broadcast domain we have. Hub has got 8 ports. So tell me what is the total number of collision domain and broadcast domain. How one? Correct. So this side one, I told you. This side. Mhm. No. No, Priya. This collision domain. This broadcast domain is what shared with the 96. So this is 96 plus 1. This side is 1 now. Here is also one collision domain. That is what shared here. So this is one collision domain. This is another collision domain. 96 plus 1 is 97. Correct? Hmm. Don't forget, I'll test you these things later after 1 week. All right. Our next topic is IP addressing. IP addressing. See, when I say it is too early, very long back, very long back, there was no internet actually. But the US government was having a secret communication using an address. That's the address that we are calling it today as IPv4 address. Yeah, this IPv4 or IP address. This is a version 4 address we are talking about. IPv4 or IP address, both are same. If someone says IP address, it means IPv4 address, version 4 address. Now, this address is what initially used by US Army for secret conversations, communication. It was only designed to support the military, not the entire world. So, this US military was using 32 bits of binary as the size of IPv4 address. It is only 32-bit binary using which the entire military was communicating. Later, it was given to the whole world. First, it was military, the one which was using this. And then it is given to the whole world. 32-bit only. How can it be sufficient for the whole world? To achieve this, there are a lot of schemes like private address scheme, uh, NATing, much more has been done to provide internet to the entire world with just 32-bit. Now, this 32-bit binary is used by not only the technical people, even non-technical people. So if it is in a binary format, like 1 1 0 1 1 1 0 1 0 0 0 1 1 0 1. Don't write this. I'm just simply writing some numbers like an LKG student. See, this is 32-bit binary. If I cover this, can you remember them? No, you cannot remember them. You don't know. I don't know whether you may remember, but I cannot remember. I don't know really how many zeros were there, how many ones were there. Though I wrote it, I don't know. I don't remember. You see, it is not that easy to remember the zeros and ones. So, for the human to use it comfortably, to use it without any uh, struggle, they decided to break this 32-bit into 4 equal parts. So they have come up with 8-bit dot another 8-bit dot another 8-bit another 8-bit. So the entire 32-bit they divided into 4 groups. Each group has got 8 bits. So this is what we call it as octet. 4 octet, 4 octet. IPv4 is 4 octet. Each octet is separated by a decimal, a dot decimal. 1 dot 1 dot 1 dot 1. We write 1 dot 1 dot 1 dot 1. You know how this is how it is. If all these bits are 0 and it is only 1 here, this is what we call it as 1 dot 1 dot 1 dot. This equivalent decimal is 1. 1, 1, and 1. 1 dot 1 dot 1 dot 1. That's the IP address that the human being can easily manage. The 0001 and all we cannot remember. But if someone is saying 1 dot 1 dot 1 dot 1, I know I can remember this. Easy. Because this decimal value is what we daily use in our market, in our buying and selling. So this is what they did. They took the 32-bit, they divided into 4 equal half or 4 equal parts, and they converted this decimal into, binary into decimal. So that normal people and non-technical people can comfortably use this IP address, can remember this IP address. Now, we need to understand This is 8-bit. If you understand 8-bit, you can understand the entire 32. Why? Because the entire 32 is divided into 8 bits or 8 bits. Now let us go to some max class. 1, 2, 3, 4, 5, 6, 7, 8. இந்த 8 பிட்டை நல்லா புரிஞ்சுக்கிட்டோம்னா மொத்த ஐபிஆர்எஸ் புரிஞ்சுக்கலாம். ஏன்னா மொத்த ஐபிஆர்எஸ் இதே மாதிரி 8 பிட்டா பிரிஞ்சிருக்கு. 4 8 பிட்டா பிரிஞ்சிருக்கு. ஸோ ஒரு 8 பிட்டை புரிஞ்சுக்கிட்டா போதும். இதெல்லாம் ஈஸி. Let's try understanding this 8-bit. You see, it is binary, no? Binary means you have only two numbers. There is no third number. See, the decimal equivalent of this is 0. This is 1. In decimal, you have 2, 3, 4, 5, 6, 7, 8, 9. In decimal, there is nothing more than this. That is why it is decimal 10. You have only 10 numbers, 0 to 9. There is no other number in decimal. When you write 10, is it a fresh number? No. You have taken these two. Likewise, in binary, there is only two numbers. If you say 1 0, it is not fresh number. It may indicate 2, but is it a fresh number? No. You have used this one and this one. So binary is only 2. That's why we put 2 to the power of 0, 2 to the power of 1, 2 to the power of 2. 0th place, 1st place, 2nd place, 3rd place, 4th place, 5th place, 6th place, and 7th place. 2 to the power of 0 to 2 to the power of 7. Binary. Now, when I have 1, 1, 1, 1, 1, 1, 1, what does it mean? It means that, which is 255. How? 2 to the power of 0 is 1. Every face values. See, 2 to the power of 0 is what? 1. 1 multiplied by 1 is 1. 2 to the power of 1 is 2. 2 multiplied by 1 is 2. 2 to the power of, no, listen. 2 to the power of 1 is what? 2. Yeah, at last, later we'll add later. Now 2 to the power of 2 is what? 4. 4 multiplied by 1 is 4. 2 to the power of 3 is what? Exactly. 8 multiplied by 1 is 8. 2 to the power of 4 is what? Exactly. So if you multiply this again by 2, 16. And likewise, this is 32, 64, and 128. And when you add all these face values, you will get this value, 255. Yeah? So there is no number other than 1 to 255 in an IP address. Take any IP address on earth. It will be less than 255, and it will be only between the range of 1 to 255. You will not see anywhere address 300 dot 400 dot nothing. There is nothing like that. With the 8-bit, you cannot get more than 255. So, IP address is 32-bit address, but for our human comfort and human understanding, it has been separated by 8 bits 4 times using a dot, using dots, 3 dots. And it is binary, that is why we say 2 to the power of 0, 2 to the power of 1, 2, 3, 4, 5, 6, 7. And when all the 8 bits are on, see, binary can be 0 or 1. When we say 1, it means on. When we say 0, it means off. When all the 8 bits are on, the total amount of the face value is 255. Now I'm going to give you one exercise. You're going to tell me the face value. I have 0, 0, 0, 0, 1, 1, 1, 1. What is the value? Which means this is 0, this is 0, this is 0, this is 0. Uh, what is the answer? 15. Right. Good. Now let us do another one. Priya is great. 1, 1. Very nice. I'm happy. 1, 1, 1, 1, 0, 0, 0. What is the value of this? I'm giving tough one immediate because you said you are good in mathematics. See, Priya, you were correct up to here. You said here 192. I heard you, and when you counted this two, you said 192, and when you counted these three, you said 224. Good. Then what is the value? Exactly. Clever. Good. Okay. Now let us move on to another one. 1, 1, 0, 0, 0, 1, 1. What do you get? Okay. So from now on, you should understand. See, we have only 8 bit. ஒவ்வொரு முறையும் 128 plus 64 அவ்வளோ வேண்டாம். இது ரெண்டும் ஆனா 192. இது நாலும் ஆனா 240. You understand? இது மூணும் ஆனா இருக்கா அப்போ 224. இது மூணு ஆனா இருந்தா 224. எப்படி ஞாபகத்துல வச்சுக்கணும். ம். அப்புறமா இது 5 ஆனா 248. ஏன்னா இது வரைக்கும் 240ன்னு பார்த்தோம். இன்னும் ஒரே ஒரு பிட்டு 8 அது 248. இப்போ இது மூணு ஆனா 7. ஓ சாரி, இது மூணு ஆன் சொன்னா 7. இது நாலும் ஆன் சொன்னா 15. அப்படி ஞாபகத்தில் வச்சுக்கிட்டோம்னா சீக்கிரமா பண்ணலாம் இல்லையா? சரி, ஃபர்ஸ்ட் 2 ஆனா 92, 192 பிளஸ் 3 195. ஈஸியா போட்டாச்சு இல்லையா? ஃபர்ஸ்ட் 3 ஆன் ஆயிருச்சுன்னா 224. அப்புறமா இதெல்லாம் ஆன் ஆயிருச்சுன்னா 224 பிளஸ் 7 231 இல்லையா? ஈஸி ரைட். இப்போ நான் கேட்கட்டுமா? இப்போ நான் கேட்கிறேன். 11111110. இது எப்படி பண்றது? 255 மைனஸ், டெல் மீ. டோட்டலா எல்லாமே ஆன் ஆயிருந்தா 255 மைனஸ் அவ்வளவுதான் 252. We are the great. Now let's do this. 11101111. இது எப்படி போடுவீங்க? Easy. 255 minus in the value 16. So what do you get? Okay, 239. Good. All right, so easy for you, no? Now let us do one thing. Now I am going to write some randomly. I'm simply writing something, and you're going to tell me the IP address. Okay. Now tell me the equivalent decimal of this. What will be the IP address? If this is written in binary, what will be the decimal IP address of this? That's putting, huh? Okay. Very good. Twentieth, 30th. Next. That's all. You have done. You know what? This is what called as class D address. In IPv6, in IP address, we have class A ranges from 1 to 127. Class B ranges 128 to 191. Class C ranges 192 to 223. And then class D 224 to 239. You see, this is less than 239. It is in between these two, right? So this address is a class D range address. First octet, only the first octet. Class D is called as multicast range. Multicast address. Class D address வந்து யாரும் ஒரு பிசிக்கு கொடுக்க மாட்டாங்க. ஏன்னா அது வந்து ஒரு மல்டிகாஸ்ட் அட்ரஸ். அது நிறைய டிவைஸ் ஒரு பெரிய குரூப் ஐடென்டிஃபை பண்றதுக்கு யூஸ் ஆகுற அட்ரஸ். மல்டிகாஸ்ட் அட்ரஸ் வந்து ஒரு இண்டிவிஜுவல் டிவைஸ் கொடுக்க மாட்டாங்க. அதை பத்தி நம்ம அப்புறம் படிக்கலாம். பட் கிளாஸ் ஏபிசி இருக்கு. These are unicast address. These will be assigned to computers. So in our next class, we are going to start here. What is the title? Our next class will be IP address classes. Classifications in IP address. That's our next class is on